So here's our precise definition. So what do I need you to do with this? One, I need you to memorize that. Write it down, put it on a big piece of paper and stick it to your ceiling and stare at it before you go to bed. And I need you to be able to just kind of think about it intuitively. Intuitively, it's a dare, right? Somebody says, get within epsilon, that small number, of the limit L. And then what we do is we find a range of X values to get there. And that range of X values is always going to be centered on A, and then delta is the distance we can possibly get away from A. So A is always going to be in the middle, and then we can look out delta to the right or delta to the left. And this right here would be my range of numbers. Easy idea, crazy definition, hard to do in practice. We're just going to do some very simple problems. So I'm going to pick f of x equals 1/3 x plus 1 as my function. I'm going to let a equal 2 here, and I'm going to dare somebody to get within epsilon equals 0.1 of the limit. Let's find the limit. So my claim here is that the limit as x approaches 2 of this function 1/3 x plus 1 is equal to, now this is a polynomial, which means I can cheat here. 2 times a third is 2/3, plus 1 would be 5/3. I claim that the limit is 5/3. To prove that, I got to follow through with the dare and come up with a range of X values and be able to say how far away I can afford to get from 2, but still be close enough, right? This right here is close enough to 5/3. So the way it starts is we just kind of work backwards from here to do this. We reverse engineer it. We plug everything we know into that expression right there. So I'm just going to rewrite that expression down here. Absolute value of f of x minus L has to be less than epsilon, and then I plug in what I know. I know that f of x is 1/3 x plus 1 minus, I know L is 5/3, and then I know epsilon is 0.1. And then my work backwards is to make this thing right here look, let's use a different color, look like that thing right there. So instead of an f of x minus L, I want it to make it look like x minus A. So all I have to do is just do a little algebra on this. So it looks like, so again, I'm going to make it look like absolute value of x minus 2 is less than delta y2, because that's A. And then I can figure out what delta is. So let's do it here. So I can clean up the inside of this absolute value here by taking 1 minus 5/3. 1 is 3/3 minus 5/3 is 2/3. So this simplifies to 1/3 x minus 2/3. And that's less than 0.1. So I'm just cleaning this up, trying to make it look like that. Okay, well, I'm getting closer. I have a subtraction here. That's a good sign. If only that 1/3 wasn't there. Well, if I multiply both sides by 3, then that 3 is going to distribute through here because it's positive. It won't mess up the absolute value. And I'm going to get rid of those thirds in the bottom. So 3 times 1/3 is 1. So I'm going to have the absolute value of x there. Ooh, that's awesome. I want that. Minus 3 times 2/3 is 2. Holy crap, this is working out nice. And then the other side, I want it to be less than 0.1 times 3 is 0.3. So this must be delta. Hello, delta. So when someone dares me for this limit to get within 1/10 of 5/3, all I have to do is say, hey, pick any x value that's within 3/10 of 2. And that will get you close enough to 5/3, the limit. Now, often we don't know what that limit is, but that's okay. So pretty straightforward for linear functions. For other kinds of functions, it's much, much, much harder. We're only going to do a few examples of this. The homework here is pretty short, but it is a wee bit challenging because we're pushing our algebraic abilities with this crazy dare.